We should probably start writing some tests now. We have two major functions in process that are actually quite complex, that are the attach and the launch functions. Uh, so we'll write test for launch first. So launch, what it does is it forks and then it execs a new process in the child process. Back in the introduction, I told you to create this test folder and this empty test file. So we will remove that. We will write some tests now in here. So let's rename it to test underscore process underscore launch underscore success. And in here, I want to launch a process and then I want to check if that process is running. That's what launch does, right? So let proc equal to process, sorry, launch, and let's give it a program path. Let's run the yes process and let's unwrap it. And if that fails, then the test fails. And we can assert that I want I want a way to test to check if a process is running or not. So let's create a function for that. Process underscore running, and I need the process ID from it. Sorry, it should be named proc and proc dot pid. So we will check if that process is running or not through that function, and after checking I can actually drop the process. So proc. All right, so let's create this function now. I want a way to check if a process is running or not. So pid, and it returns a bool. All right, how can we test if a process is running or not? So in Linux, whenever there is a process that is running, Linux actually creates virtual uh, process directories for you, virtual process file system for you. So it creates a file uh, at a folder for that particular process using the proc ID. So uh, if there is a process running with pid 123, then there must exist a folder called proc slash 123. That is if there is a process running with process ID 123. So proc is a special directory on Linux. It's a virtual file system. It doesn't actually exist. Linux creates it for you, and this is how we can inspect into processes by checking these virtual files. And each running process has a directory named after its PID. So I want to check if this directory exists or not. So path, your standard path, new. I want to create a path and format. Let's say proc slash pid, and it takes a reference, I think. Yeah. So path, and I want to check if it exists. And with this, we should be able to test if a process is running or not. So let's go to WSL. Let me open a new terminal. Right, let's cargo test it. So this test works. So that's a positive test case. That's a good happy path. We should also test negative test cases. And I'll try to run a process that doesn't actually exist on my uh, WSL. So I'll give it any random path instead of yes, and hopefully that random path doesn't exist as path variables on my WSL. So the launch function, uh, how can we test it? So the launch function forks into two processes, and the parent process returns an OK, and the child process doesn't actually return anything. It has unreachable code. So whenever exec happens, this doesn't return anything. How can we test a function that doesn't return anything? We can only check its side effect or make or force it to return something. Let's make it return an error in case a child process fails. So if a child process fails, let's make it return an error. How can we do that? Uh, right now, this process forks into a parent and a child, and there is no way for us to tell the parent process that the child process has failed. So we need to set up a way of communication between the two processes. Okay, so we'll explore two ways of testing it. So the first way is to set up a way of communication between the two processes, and the other way is to uh, wait for it and then check if the process has failed. And if the process fails, this directory should get deleted. So if the child process fails, this directory should be deleted. So maybe we can test it that way. Let's create a function. So test, and let's call it fn test process launch non-existent process process. And in here, let's launch a random as process launch random non-existent path, hopefully. So hopefully this part doesn't exist on your WSL environment variables as well. And this returns a result, right? So let's just unwrap it. And if that unwrap fails, then the test fails. We can wait for it actually. Let wait result is equals to wait pid, and wait pid takes a pid, so pid, and it takes an option as well. So let's give it none for now. Unisted. I imported it from the wrong library. Import next syswait. All right, let's wait for it, and let's match on the wait result. And in here, okay, so I don't want anything. I don't want the result of wait. I don't want to do anything with it. I just want to assert that now the directory should have failed. Like the directory doesn't exist, so this function should fail. Should return a false. So not of process running and proc dot pid. And right here I should assert false, because if wait fails, then let's fail the test as well. So should we try to run this now? Cargo test. All right, this test works. But if you were to look carefully, in case the child process fails, this directory is only cleaned up when we wait for the process once, and only then does it get cleaned up. So if the parent or the thread that created the child process doesn't ever wait on it, then the child process is never cleaned up even if it fails. And that is bad. So right here, instead of exiting out, we should inform the parent process that this process failed. And in that case, I should call drop on process. That is only if the child process failed. So I need a way to communicate from the child to the parent. And the way to do that in Linux is by using pipes. So let's do some TDD now. Let's do some test driven development. Let's comment this code. In case the child fails, I want process.launch to actually return an error if the child fails, even then. So test and fn test. Let's copy this function name. Let's rewrite this test to the way we want our launch function to behave. Process launch and random non-existent, and right this time we won't unwrap it because this should be an error. I want it to be an error. So let's match on proc, and in case of OK, I will say assert false because this should have failed. It should not have been OK. And right here I'll say assert true because this should have failed. This is what I want. This is how I want the test to be. This is how I want the launch function to behave. That if even the child function fails, I want it to return an error. So I guess this doesn't work now. Hmm. It doesn't. And let's see, what does it say? Assertion failed on line number 36. Assert false because it didn't return an error. Because the child never told the parent that it failed, and process or this parent always returns an OK of process. So I don't want it to return an OK in case the child fails. So I want to set up a pipe. I told you, right? Uh, we can make two processes communicate with each other using pipes. So let's set up a pipe between the child and the parent. And as you can guess from the name, how pipes work are you send data through one end and receive from the other end. That's how pipes work on Linux. Uh, it's a one-way communication channel. So let's create a pipe, and we have the pipe function. Do not use the libc implementation. Do not use that one. Use this one, unisted, and pipe let hmm, pipe dot map error. And in case it errors out, I want to return a string. So let's say pipe failed, and let's give it the error. Oh, sorry, my bad, guys. We need to put it in a format and let so x equal to the return type is two FDs, right? So those are actually the read FD and the write FD. These are the objects through which we can read and write the data. And let's just question mark. So we can, these are the ends of the pipe. This is the read end of the pipe and this is the write end of the pipe. We can push in data from this end and read in data from this end. right? So in the parent, I only want to read. So we should close the write end in the parent process, because we are calling the fork after the pipe. So both the processes actually inherit these pipe ends. And I don't want to write data from the parent. So let's just close it. We have a function to close it. Import it from Unisted, close, and close the write FD, and then say OK. Similarly, I want to close the read end in the child, read FD, closed. And let's write to the pipe whenever error happens in the child. All right, in here, error happens. So we want to write. So we have a function called write, of course, imported from libc write. No, let's pass in a reference to the write fd, and let's now try to import it. Where is it? Where is the write being imported from? Let's try to import it now. Next p trace next unisted. Yes, I think so. Yeah, and what do I want to write to it? I want to write to it a string that is telling me what the issue was. So format, and let's say tracing child. Let's just print this, right. So it expects a buffer. It expects a vector of U8, a vector of bytes. So as bytes. So now we are writing, and after writing, we should actually close the write FD as well. This is one place that there is happening an error, and the other place is right here. So let's write exec failed right here. Exec failed, and then we closed the write FD. So now whenever an error happens, I am letting the parent, I'm writing to the pipe. Now I can read the data from the pipe in the parent. So we have a function for it as well, of course. Uh, let's create the process first, and now read, and we'll read from the read fd, and let's try to import it. Import it from unisted. And what does this function take? This function also takes a array of bytes. So let's create that. Let buffer equal to, and let's create a buffer of size 256. Let's explicitly give it a data type u8 and size 256, and we can give in the buffer, but it's a reference and a mutable reference. uh, but this needs to be mutable as well. All right, and this returns a result of u size. So this u size must be the number of bytes read. So should we, so it's a result. So let's unwrap, but this will throw an error. So it will panic. So instead, if nothing was read from the pipe, let's just say 0 bytes read. And after reading, I should actually close the read FD. And to do that, I need to pass in a reference. Dot OK. After closing the read FD, I should check if we read something from the pipe. That means the child process wrote something to the pipe. So if the child process wrote something to the pipe, that means there was an error. So in that case, I should drop the process and I should return an error. And what should the error message be? Let's say the error message is child process failed with error. The error is the error. So the error will be the thing we read into the buffer. So we need to convert it into string. So let error message equal to. So we only read this many. So the buffer only this many bytes of the buffer have any value, right? So we should create a slice out of it. Buffer slice till bytes read, and this is a u8, but I want it to be a string. So do we have a method dot to ASCII lowercase? Do we have string? No, we don't. Do we have a method in string from something that takes an array of bytes? This takes an array of bytes. All right, so let's give it an array of bytes. Expected a reference. So let's create a reference. And what does it return? It returns a cow of string. What the fuck is a cow? I don't know. What the hell is this? Borrowed or owned? I don't know. Do we have dot to string? Yeah, we do. All right, great. And let's give it the message. And we need to put it in a format. Huh. So now whenever the child process fails, it writes something to the pipe. And in the parent, we read from the pipe and return an error if we read something from the pipe. Do you think, do you guys think this will work? Let's try to run it and see. Uh, so the tests passed, but do you see that it is blocked? We can't. Uh, the process is still running. It never closes. Why is that? Let me show you that this doesn't keep running because of this test. If I comment it out, it will still keep running. See, it's still running. Why is that? I'll have to manually close it with Control C. So that must mean that it's running because of this test. So something about yes is causing the issue. Cargo run yes. So our debugger never comes alive. Why is that? If I do Control C, it stops. Uh, that is actually because when uh, whenever this happens, that is because when exec fails, we write to the parent process, right? Whenever it fails, we are writing to the parent process, but we are not writing to the parent process if this is successful, right? And this read call, this read right here is thread blocking. So in case of success of exec, it still keeps waiting. It's waiting for something to be written to the pipe. And that's why the thread is blocked. So we need a way to close this thread. This read keeps on waiting till till something is written to the pipe, or till the pipe stays open. As you can see, in case of success, the pipe is never closed right here. We close it here in case of error, but it's never closed in case of exec success. In case of exec success, and if exec works successfully, the control will never come to this line. It will never come here. So I can't manually close it. So we need to do some pre-processing. When we create the pipe, I need to configure it to close if an exec happens. So whenever an exec happens, I just want that these pipes should be closed automatically. So I will copy and paste two lines right here, and those lines will do exactly that. Let me import them first. And this one, and this one. What these two lines will do is it will close this. What these two lines will do is this line will close the read end of the pipe in case an exec works successfully, and this one will close the right end of the pipe in case an exec happens. And then uh, this right end will be closed whenever this exec works successfully, and the thread will be unblocked, and byte thread will be zero actually. So let me show that to you that it works. Cargo run yes now, and you can see the thread is not blocked now. My debugger comes alive, and if I press C, uh, the process runs successfully. And Control D will close it. And now the both the test should run, and my thread should not be blocked. Cargo test.